Alright, so starting on number 42, we're going to be doing some factoring here. Notice on 42, x squared minus 36, that's a difference of squares. So we know we can factor that as x minus 6 times x plus 6. And let's look at number 43. 43, we've got 4 terms, so factoring by grouping should be your first thought. And in fact, that's what we're going to do here. So let's go ahead and group the first 2 terms. We can factor out an x squared. X squared times x will be the x cubed, and x squared times a minus 3 will give us the minus 3x squared. So now when we factor here, now you can factor out a negative 4 times x minus 3. I usually will rewrite the x minus 3 because I know that I should get the same thing in both parentheses here. And I can see that I need negative 4 times that x to get a negative 4x. And notice negative 4 times negative 3 gives you the 12. So let's see, our common factor is x minus 3. If you cross out the x minus 3's, you can see the other factor is x squared minus 4. And again, we have a difference of squares. We can write x squared minus 4 as x minus 2 times x plus 2. So we get 3 factors here. On number 4, we've got 3 terms. This is looking like we're going to be able to use the AC method. And so we need 2 numbers that multiply to AC, 1 times 12, or just 12. Oops. And that add up to negative 8. So let me write the factors of 12 here. When we multiply 2 numbers and we get a positive, they must both be positive or negative. Since these numbers add up to a negative, they must both be negative. So you can see the one that works here is going to be negative 2 and negative 6. Notice negative 2 times negative 6 is 12, and negative 2 plus negative 6 is negative 8. Now, I'm going to go ahead and do this the long way, but we could actually take a shortcut here because this is a 1x squared. I'm going to split our b term into using the minus 2 and then the minus 6 we just got. Notice negative 2x minus 6x is negative 8x. And so now we'll factor by grouping. We can factor out an x there times x minus 2. So we expect to get an x minus 2 factor here. And a negative 6 times x will give us that minus 6x. Negative 6 times negative 2 gives us the 12. So I end up with x minus 2 times x minus 6. So again, you can see we had the factors negative 2 and negative 6 that we could have put in here directly. So these 2 steps here were actually optional. But if you don't see that, you know, for some people it's easier to just do things the long way every time. Let's go ahead and look at number 45. Again, you ought to be thinking AC method because you have the 3 terms there. There's no greatest common factor here. So notice AC is 48, 6 times 8, and B is 19. So we need to find 2 numbers that multiply to 48 and add up to 19. Here's all my possible factors of 48. And notice 3 and 16 are the ones that are going to work here. So again, no shortcuts here. We're going to have to split our b term into 3x and 16x. And let's bring down the 8. So let's go ahead and factor the first 2 terms. Our GCF here is 3x. So it would be 3x times 2x would be the 6x squared, and 3x times 1 would be 3x. So when we factor these 2 terms, we expect to get a 2x plus 1. And 2x times 8 would give us the 16x. And notice 8 times 1 is 8. So finally we get 2x plus 1 times 3x plus 8. And the other thing I would just mention is we can always multiply and go in reverse, and we should get what we started with. If you FOIL on number 45 and 44, you'll get what you started with. And similarly, you can multiply what you got for answers on 42 and 43, and you should end up with the answer that you started with. Let's go ahead and move on to 46. So here we have a rational equation. We need to find a common denominator. So this one actually, it turns out that the hardest part about this problem is just finding the LCD here. I'm going to start with the biggest number, which is 5. I look at the factors of 5 until I find one that's divisible by 2, 4, and 3. So notice 10 is not divisible by 3 or 4. 15 is not divisible by 2 or 4. It's got to be divisible by all of them. In fact, it takes you a while. You've got to keep going until you get to 60 before you find a number that's divisible by 2, 4, and 3, and of course 5, since we're looking at multiples of 5. So 60 is your LCD here. Notice there's no restricted values because we don't have a variable in the denominator of a fraction. Let's multiply everything by 60. Notice 60 over 2, that can cancel and you get 30. 60 by 2 is 30. Times the x that's already there. 60 divided 4 is 15. And it's minus 15 times 1 there. Equals, on the other side we have 60 divided 3, which is 20. Times the x that's there. And then 60 divided 5 is 12. 12 times 1 is 12. So we've cleared fractions. Now we need to get x on one side only. Let's go ahead and subtract 20x on both sides. And this is going to take us 2 more steps. We're going to have to add 15 to each side. And we get 10x equals 27. To get x by itself, we have to divide by 10. So I'm going to rewrite this and divide by 10 on each side. And so we do get 27 over 10. And that is reduced. You could write it as a mixed number, but it's perfectly fine the way it is. Look at number 47. This is just like solving an equation, except for when we get our answer, we're going to get more than just one answer. We'll write our answer in interval notation. And the other thing is, if we divide both sides by a negative at some point, or multiply by both sides by a negative at some point, we have to reverse the inequality. So first thing here, we have some simplifying to do. Let's go ahead and distribute here. You get 3x minus 6 on the left. Less than or equal to 5 times 3x is 15x, and 5 times a minus 18 is minus 90. It's kind of like what we just did on the previous problem. We're going to need to get x on one side only next. So subtract 15x on both sides. Get negative 12x minus 6 is less than or equal to negative 90. So let's go ahead and add 6 to each side. We get negative 12x is less than or equal to negative 84. Now notice we need to divide by negative 12 here. I'm just writing it up here where we can have a little more space. When we do that, though, we're going to have to flip that symbol. And so this becomes x is greater or equal to 7. So if you actually graph that, it would look something like this here. Let's see, we're shading to the right of 7. Those are the numbers greater than 7. And since we're including 7, we'll put a bracket there. That's a picture of the graph, or that is the graph of the set of numbers where x is greater or equal to 7. Again, that just represents the numbers that are greater or equal to 7. Going from left to right, we start at 7 and we go forever right. We call that infinity. Let's move on to number 48. Now there's 2 rules of exponents that we're going to need here. The first one, I'll just do an example here, a cubed squared. When you have a power to a power, you multiply your exponents. So that would be a to the 6th. The other rule is what we call the product rule. If you have a product of 2 powers of a here, so a to the 3rd times a to the 4th, we just add the exponents. So that's what we call the product rule. The first one, where you have a power to a power, that's the power rule, and that's where we multiply the exponents, or the product rule, we add the exponents. So we're going to first take the fourth power of everything inside the parentheses on the first problem here, or on the first parenthesis. Sorry, I'm getting tired here, I'm yawning. So we have x to the fourth. We have y squared to the fourth, so a power to a power. We'll multiply our exponents, we get 8. We have z cubed to the fourth power, again a power to a power. So 3 times 4, we're going to get z to the 12th. And of course, w to the fourth, there's nothing more to do there other than just write the power on the w there. We'll do the same thing in the second parentheses. We've got x squared cubed, so we'll multiply our exponents there. Notice we're multiplying these two together. That's what we do when we have parentheses next to parentheses. We've got y cubed, and then y squared cubed. We'll multiply our exponents there, and we get w to the 6th. And so now we're going to multiply across. Notice we have x to the 4th times x to the 6th. That's x to the 10th. Y to the 8th times y to the 3rd. When we add our exponents, we get 11. Don't forget about that z to the 12th. And in the denominator, 4 plus 6, we're going to get w to the 10th power. And that's all we can do. Let's go ahead and move to 49. This is what I call FOIL in disguise. You can't just square the 2x and the 5y separately. You've got to rewrite this as 2x minus 5y times itself. And then we just FOIL. So we're going to get 4x squared, the first product. The outer product is going to be a minus 10xy. Multiply the inner terms there, you're going to get a minus 10xy. Again, let's put our x and y in alphabetical order here, so both of these terms look like terms, and they are. Then we have a negative 5y times a negative 5y, that's going to be 25y squared. And of course it's positive since you have a negative times a negative. We do have two like terms here, so let's combine those. We'll get a minus 20xy. And so that's our final answer. All right, we're almost done here. Let's move on to number 50. So to simplify a square root, we want to ask ourselves if there's any perfect square factors of 75 other than 4. I'm sorry, other than 1. So we're talking about these kinds of numbers here. Notice that 25 is a factor of 75, so this radical is not simplified. We can break it into square root of 25 times square root of 3, which is the 5 times the square root of 3. On number 51, notice it's the square root of a negative, so we're going to get an I out of this one. It's going to be an imaginary number. Let's go ahead and write it as square root of negative 1. Notice 9 is a factor of 45, so 45 has a perfect square factor. So we can break this down into square root of 9 times square root of 5. And square root of negative 1 is I, and the square root of 9 is 3. We're going to get 3i times square root of 5. All right, number 52, we've got a garden. We're going to put up a fence. It says in order to fit correctly, the length of the garden must be 1 foot less than twice the width. If she purchased 82 feet of fence, that's going to be our perimeter. For the perimeter of her garden, what must the length of the garden be so that she uses all of the fencing? All right, well, let's see. Let's draw a rectangle. And it says the length of the garden must be 1 foot less than twice the width. So the length must be, or is equal to 1 less than twice the width. Well, twice the width is 2w, and we want 1 less than that, so we'll subtract off 1. So when you read that, it says the length of the garden must be 1 foot less than twice the width. That's how we would translate that. So for our other equation, notice we have a length, or a width and a length here, and there's a formula for perimeter. It's P equals 2W plus 2L. Since the perimeter is 82, we can go ahead and write an 82 for for the perimeter. And so here's our other equation. So this is pretty much set for us to do substitution. So let's go ahead and we'll substitute 2w minus 1 for L right there. So we're going to get 82 equals 2w plus 2 times 2w minus 1. We're going to go ahead and distribute there. We're going to get 4w minus 2. And we can combine our w terms. We get 82 equals 6w minus 2. And let's add 2 to both sides. And then divide by 6. And we get w is equal to 14. Now we weren't asked to find the width. It actually said to find the length, although we normally find both. So we know our width is 14 feet. Our length is 2 times the width minus 1. So let's plug in the 14 that we just got for the width. 28 minus 1 is 27. And so our final answer for the length is 27 feet. All right, on number 53, 4 to the negative 2 power, we've learned that negative exponents lead to reciprocals. If we know 4 squared is 16, then we know 4 to the negative 2 is 1 over 16. The other way to get to that is just to write this as 1 over 4 squared, which is 1/16. Notice I did not use a decimal there. On number 54, it says rewrite using rational exponents. So that's fractions for exponents. And we learn that the denominator of our fraction is going to be the root, which here is 4. The numerator will come from the exponent that's on z. So this is z to the 3/4 power. And then, all right, we're on the last problem here. This says rewrite the following using radical notation. So we can write this as a radical. The denominator of the fraction tells us the root, so it's a 5th root. And notice the numerator is just going to be the exponent on x. Now I could put the 6 on the outside. We can do it either way. And that's the end of this review.